The effects of creatine loading and gender on anaerobic running capacity. Metabolic and Body Composition Laboratory, Department of Health and Exercise Science, University of Oklahoma, Norman, Oklahoma. Applied Biochemistry and Molecular Physiology Laboratory, Department of Health and Exercise Science, University of Oklahoma, Norman, Oklahoma. Biophysics Laboratory, Department of Health and Exercise Science, University of Oklahoma. Abstract. The effects of creatine loading and gender on anaerobic running capacity. Journal of Strength and Conditioning Research 24/7, 1826, 1833, 2010. Creatine, CR, loading consists of short-term, high-dosage CR supplementation and has been shown to increase intramuscular total CR content. Increases in body weight, BW, have been shown to result from CR loading. With differences by gender, an increased BW may impact weight-bearing exercises. The critical velocity CV test is used to quantify the relationship between total running distance and time to exhaustion. The CV test provides the variable anaerobic running capacity, ARC, which is an estimate of the anaerobic energy reserves in muscles. The purpose of the study was to examine the effects of gender and CR loading on ARC. 50 moderately trained men and women volunteered to participate in this randomized double-blinded placebo, PL, controlled repeated measure study. After a familiarization session, a 3-day testing procedure was conducted. A maximum oxygen consumption test, VO2 max, on a treadmill was performed on day 1 to establish the maximum velocity Vmax at VO2 max and to record VW. Days 2 and 3 involved treadmill running at varying percentages of Vmax. Participants were randomly assigned to either the CR or PL groups and received 20 packets of the CR supplement. 1 packet equals 5 grams CR citrate, 18 grams dextrose, or 2 packets of PL. 1 packet equals 18 grams dextrose. After consuming 4 packets daily for 5 consecutive days, a 3-day testing procedure was repeated. The male CR loading group exhibited 23% higher ARC compared to the PL group. Non-significant BW increase were found for the CR groups. These findings suggest that CR loading may be an effective strategy for improving ARC in men, but not in women, and revealed only non-significant increases in BW. Creatine loading may be used before competition by athletes to provide improvements in high-intensity, short-duration activities. Introduction. The phosphocreatine PCR energy system aids in the rapid production of adenosine triphosphate ATP during high-intensity exercise. Creatine CR loading has been proven to significantly increase PCR stores and provides additional substrate that can be used by the PCR energy system during the production of ATP. Increased availability of ATP augments high-intensity, short-duration exercise performance. In addition to increased anaerobic exercise performance, CR loading has been shown to cause weight gain in men. Further research suggests that this increase in body weight, BW, is primarily because of acute water retention in skeletal muscle. Long-term CR supplementation in combination with resistance training has been shown to increase fat-free muscle mass. Interestingly, despite comparable changes in exercise performance, CR loading research with women has failed to show similar increases in BW. Body weight changes resulting from CR loading in women appear to be minimal, whereas increases in men have been up to 2 kilograms have been reported. The terms CR responder and non-responder have often been used to distinguish between individuals with a predisposition to develop physiological adaptations from CR loading. Although BW changes have commonly been attributed to CR loading, previous studies have been shown to increase in intramuscular PCR levels and exercise performance with a little to no weight gain. Therefore, CR responders can be considered the group of individuals who possess the ability to improve performance through heightened PCR stores that result from CR loading regardless of weight gain. The critical power test was developed to highlight the relationship between power output and time to exhaustion. While evaluating anaerobic and aerobic performance, the critical power test is often performed on a cycloergometer. Comparatively, the analogous test performed on a treadmill, vertical velocity, CV, focuses on the relationship between intensity or time and total distance. The CV test provides variables used to calculate CV and anaerobic running capacity, ARC. Critical velocity gives an estimated velocity at which a person can run continuously without inducing fatigue, whereas ARC gives an estimated distance that a person can run solely on stored anaerobic energy sources. Creatine loading has been shown to be effective in increasing anaerobic working capacity, AWC, the cycling equivalent to ARC. in both men and women. The mode of exercise has a point of contention with previous CR research. Weight-bearing activities that require a proportion of the body without mechanical facilitation, such as running and swimming, have provided equivocal results, whereas non-weight-bearing activities such as cycling and rowing have shown consistent increases in anaerobic performance. Therefore, the possibility of changes in BW as a result of CR loading may have an impact on running performance. Ostudzik showed improvements in sprint performance in male soccer players after CR loading, whereas Terilian et al. Showed no change in 700-meter supermaximal running. More specifically, there may be unique adaptations to CR supplementation between men and women during intense running activities. However, no one has examined the effect of CR loading in men and women on ARC.
Methods. Experimental approach to the problem. After familiarization testing consisting of a VO2 max test, pre-testing measurements via VO2 max, and CV were assessed, participants were then randomly assigned to either a CR or placebo PL supplement group that underwent a 5-day loading regimen. At the conclusion of the supplementation period, participants completed post-supplementation VO2 max and CV tests. Previous research studies showed that positive results with regard to CR loading and AWC using the critical power test employed 5 days of supplementation at dosages of 20 grams a day. The relationship between intensity and time to exhaustion during treadmill running has previously been described by numerous mathematical models. For the purpose of the study, this relationship was considered linear. The CV test results in the determination of ARC, which is the distance an individual can run before lack of appropriate metabolic substrate ATP and PCR causes fatigue. This variable was used to evaluate the effectiveness of CR supplementation on anaerobic energy systems. The purpose of the study was to examine the effects of gender and CR loading on ARC. More specifically, the impact of the potential BW changes associated with CR loading was measured using a sensitive anaerobic index, ARC, via the CV test stratified by gender. Therefore, the dependent variables ARC and BW were examined before and after 5 days of CR or PL loading. Subjects: 50 recreationally active 1 to 5 hours a week aerobic exercise resistance training or recreation sports college-aged men, and 24, and women, and 26, volunteered to participate in this study. All procedures were approved by the University of Oklahoma Institutional Review Board for human subjects, and written informed consent was obtained from each participant before any testing. Supplementation history was also recorded to ensure that none of the participants had taken any supplements within 3 months before their initial testing date. Procedures. VO2 max treadmill test. All VO2 max tests were performed on a calibrated treadmill, Woodway Pro XL, Waukesha, Wisconsin, USA. Before beginning the VO2 max test, participants were connected via a mouthpiece, Hans Rudolph 2700, Kansas City, Missouri, USA, and breathing tube to a metabolic cart, Parvomedics True 1 2400, Sandy, Utah, USA, which was used to analyze oxygen and carbon dioxide parameters to determine VO2 max. The VO2 max test protocol established by Peak et al. Was employed to the test began with an initial speed of 10 kilometers an hour and 0% grade. The speed was increased by 2 kilometers an hour increments every 2 minutes until the speed reached 16 kilometers an hour. Thereafter, the speed was increased 1 kilometer an hour every 2 minutes until VO2 max was achieved. This test was determined when the participant could no longer continue despite verbal encouragement. A maximum velocity attained during VO2 max test was determined V max. All gas exchanges data were collected using open circuit spirometry via metabolic cart, Parvomedics True 1 2400. The highest 15-second VO2 value during the VO2 max test was recorded as the maximum oxygen uptake, VO2 max, if it coincided with at least 2 of the following criteria: plateau and heart rate, or HR values within 10% of the age predicted HR max. Plateau in VO2 max defined by an increase of no more than 150 milliliters per minute. Respiratory exchange ratio, RAR, greater than 1.15. Determination of anaerobic running capacity. Based on each participant's performance during the VO2 max test, 4 treadmill velocities were selected as percentages of individual Vmax values so that each run lasted between 3 and 20 minutes. Each testing day began with a 5-minute period of self-paced walking or jogging and practice for stepping on and off the treadmill, followed by a 3-minute passive recovery. The treadmill was then set to a selected velocity and 0% grade. Each run was timed and recorded until participants could no longer maintain the selected velocity and grasp the handrails to indicate exhaustion. A total of 4 runs were split between 2 days with a 15-minute rest period between each run. Day 1 involved treadmill running at 110 and 90% of Vmax, whereas 2 involved running at 105 and 100% of Vmax. The relationship between total distance and time to exhaustion was tracked for each exhaustive run. A custom-written analysis program, LabVIEW Volume 8.2, was used to perform linear regression while employing the linear total distance model, which is expressed as follows: TD equals arc plus CV times T. T is time, where TD equals total distance, time times velocity, and T equals time to exhaustion. Using this formula, arc can be identified as the y-intercept of the resulting regression line. Retest reliability data for CP and AWC from the author's laboratory for college-aged men and women, N24, measured 1 week apart, resulted in an intra-class coefficient of 0.74 with an SEM of 0.033 km. Supplementation protocol. After the pre-testing measurements, participants were randomly assigned to either the CR or PL groups. Participants received 20 packets of the CR supplement, 1 packet of 5 grams CR citrate, 18 grams dextrose, creatine edge, FSI Nutrition Fortress Systems, LLC, Omaha, Nebraska, USA, or 20 packets of the PL, 1 package of 18 grams dextrose. Participants consumed 4 packets daily for 5 consecutive days, and neither the investigator nor the participant was informed of the assigned treatment. The participants mixed the powder contents, each packet with 16 ounces of water, and consumed the resulting drink only orally, periodically throughout the day at regular intervals. The CR and PL powders and the resulting drinks were identical in taste and appearance. Participants were asked to keep the empty packets and return them to the supplementation period to verify compliance with the treatment guidelines. Statistical analysis. All data were analyzed using a current statistical analysis computer program, SPSS for Windows, version 16.0, Chicago, Illinois, USA. Descriptive statistics were used to determine group demographics, including homogeneity between groups, separate 3-way mixed factorial analysis of variance, ANOVAs, treatments, CR versus PL times time, pre versus post, times gender, men versus women, and 2-way mixed factorial ANOVAs, treatments, CR versus PL times time, pre versus post, were evaluated looking for significant differences. P is less than or equal to 0.05 between treatment groups for each dependent variable measured. Follow-up analysis included dependent t-tests, one-way ANOVAs, and post-hoc testing for effect size. The partial ETA squared and statistical was calculated and evaluated as small, 0.01, medium, 0.06, or large, 0.14. Results. Table 1 provides the mean and SD values for descriptive and performance characteristics grouped by gender from pre to post testing. Significant pre-testing differences were present between genders for both BW and ARC. P is less than 0.05. However, there were no significant differences among treatment groups, CR versus PL, within each gender category for the pre-testing dependent variables, ARC and BW. Table 2 provides a comparison of the differences for each dependent variable by gender and treatment. Body weight. Repeated measures ANOVA for BW showed no 3-way interaction time multiplied by gender, multiplied by treatment, but a main effect for time was found. P equals 0.013. Repeated measures ANOVA for each gender group indicated no significant 2-way interaction time multiplied by treatment for either the male or female groups, but a significant main effect for time was found in the male group. P is equal to 0.022. Follow-up dependent t-test showed only non-significant increases in BWs for males, approximately 0.6 kilograms, P equals 0.96, and female approximately 0.3 kilograms, P equals 0.296. 6. CR groups in the PL groups, P is greater than 0.05. Anaerobic running capacity. Repeated measures ANOVA for ARC showed a significant three-way interaction time, gender, treatment, P equals 0.042, N squared is 0.087. Repeated measures ANOVA for each gender group indicated a significant main effect for time, P equals 0.006. A significant two-way interaction times time treatment was shown for the male group, P equals 0.025, N squared 0.209, with no interaction for the female group, P is greater than 0.05, N squared 0.007. Follow-up dependent t-test highlighted a significant increase in ARC for the male CR group, 0.003, with no change in male PL, female PL, or female CR groups, 0.05. Figure 1. A one-way ANOVA showed post-supplementation values for the male CR group were significantly higher than those of the male placebo group, 0.019. Discussion. The primary finding of this investigation demonstrated that ARC increased in men but not in women. Body weight changes as a result of CR loading have been suggested to impact running performance, but only non-significant increases in weight were present in the current study for both men and women supplemented with the CR. Gender differences with CR loading have previously been compared using the relationship between power output and time to exhaustion on a cycle ergometer. However, the current study is to first examine the effects of any nutritional intervention on ARC. Previous research incorporated the use of nuclear magnetic resonance has shown increases of up to 20% in intramuscular PCR as a result of CR loading. Although the current investigation did not incorporate sophisticated substrate tracking techniques, a precedent has been set in which the effectiveness of CR loading is in increased muscle PCR content can be assumed. Body weight increases of up to 2 kilograms have been associated with CR loading. These increases are primarily attributed to the increase in intramuscular water volume and have been supported by decreased urinary volume during the loading regimen. In the current investigation, male and female BW was not significantly altered by CR loading, with mean changes of 0.6 and 0.3 respectively. Increases similar to those found in the current male CR group, 0.6 kilograms, have been found to be significant in a number of other CR loading investigations. Although an abundance of literature suggests increases in BW as a result of CR loading, previous research does not exist that supports the current findings. Stout et al. Showed no changes in BW after 5 days of CR loading in men despite improvements in AWC, further demonstrating performance increases from CR supplementation without BW changes. Body weight increases from pre to post supplementation in male groups as a whole, but no differences were found between supplementation groups, CR and PL, and no change was seen in the female group regardless of time or treatment. Although the availability body of research on CR loading supports increases in BW, the current study does not strengthen those findings. However, the lack of increases in BW may be explained by daily fluctuations in BW impacting measurements over time and the possible separation of individuals as CR responders and non-responders based on total resting CR levels in support. Erickson et al. Noted that changes in BW may not necessarily be tied to changes in total CR stores, and in this case, BW would not be an accurate predictor of the effectiveness of CR supplementation. Additionally, McKenna et al. Showed increases in resting total CR levels after CR loading in men for up to 2 weeks with no changes in BW. Fankel et al. Also observed increases in resting muscle PCR levels of men as a result of 2 weeks of CR loading with no increase in BW. As mentioned, individual fluctuations in BW and the discrepancy between responders and non-responders may influence mean changes in weight. Individual percent change scores for each gender and treatment group, figure 2, further highlighted the relative neutral nature of the changes elicited during this study. 67% of men, 58% of women, and their respective CR groups demonstrated non-significant increases in BW in the current study. Interestingly, though, 75% of the male CR group that showed increases in BW also improved in ARC. Comparably, Green et al. Noted increases in mean power and peak power from repeated Wingate testing after CR loading in only subjects that had corresponded increases in BW. Anaerobic working capacity was originally described by Monod and Scherer to quantify the total amount of energy available solely from anaerobic energy stores, specifically ATP and PCR. as provided by the critical power test, which quantifies the relationship between work rate and time to exhaustion. Anaerobic running capacity is the treadmill analog of the AWC and represents the total distance an individual could theoretically run using only stored anaerobic energy because of the inability to use aerobic energy system. This measure provided as a variable from the CV test conducted on a treadmill, which examines the relationship between time to exhaustion and total distance. Anaerobic running capacity is a useful tool and may be used in tracking changes of specific interventions such as training or supplementation. Creatine loading significantly increased the amount of available substrate used in the CR kinase reaction, which are the same constituents measured as anaerobic energy stores in both AWC and ARC, and therefore may positively influence these performance measures. The results of this current investigation revealed a significant 23% increase in ARC for the male group after CR loading compared to the non-significant 3% change in female group. Additionally, ARC and BW were unchanged in the female group post-supplementation. These findings are in contrast to initial hypothesis of the current investigation suggesting no improvement in ARC in men because of increase in BW and increase in ARC in women due to no change in BW. Although this is the first study to examine the effects of CR loading on ARC, previous data examined the relationship between CR and AWC may provide some explanation for the current study. Increased in AWC during cyclorgometry as a result of CR loading has previously been demonstrated. Stout et al. Showed a significant 9.4% increase in AWC after CR loading in men. Smith et al. And Merua et al. Reported similar increases ranging from 10 to 25% in AWC after CR supplementation. Despite the initial concern outlined in this investigation regarding the translation of AWC improvements during non-weight bearing exercise on a cycle ergometer to ARC during treadmill running, the current findings suggest that the mechanisms
on your right
triggered by
side.
CR loading, including minimal changes in BW, work in a similar manner when examining weight-bearing exercise. Further research regarding the nature of the differences between AWC and ARC by mode of exercise is warranted. Within the current study, increases in ARC were observed over time for all groups, significant for the male CR group and non-significant for all others. This finding may be explained by the intense nature of the CV test and the subsequent physiological and mental adaptations that develop over the course of the study. Regardless of the nature of these adaptations, this development further supports the findings of a significant increase in ARC for the male CR group, because any significant increase would have to overcome the pre-existing increases that appear to have occurred during the testing protocol. Eckerson et al. Previously reported an increase in AWC for women after CR loading. The current study was not able to replicate the findings of Eckerson et al. When examining ARC, but the main effect of the time may be masked by any significant improvements that occurred via supplementation. Individual percent change scores for each gender and treatment group, figure 3, also lead credence to this notion, with 75% men and 67% of women supplementing CR demonstrating an increase in ARC. Figure 3 displays the large degree of variability in the female CR group, which may have contributed to the lack of significant findings in ARC. This variability may reveal a lack of reliability in the female CR group for ARC or lack of CR responders within the sample. Evidence to support the significance of the current findings may be highlighted by gender differences in resting CR levels. Although intramuscular CR stores were not measured, it is suggested that women demonstrate higher resting levels of intramuscular CR than men and
Passing on your
therefore
left
possibly
side.
exhibit similar characteristics of CR non-responders. In theory, this would put women at a disadvantage, failing to display the same benefits as men who would be likened to CR responders. Practical application. The results from this investigation provide direct and with regard to athlete and the use of CR loading to influence short duration high intensity performance. Notably, the 20% increase in male ARC can be compared to an increase in treadmill running of approximately 60 meters, a distance that could lead to an enhanced performance in a variety of exercise settings. The current investigation revealed only non-significant increases in BW for CR supplementation for both men and women. Also, ARC via the CV test may be a more sensitive measure in men than in women when CR loading. Creatine loading may be used before competition in anaerobic athletes or mixed aerobic and anaerobic athletes in an effort to provide improvements in anaerobic running activities. This study also provides further research concerning the possible weight gain as a result of CR loading and the impact on performance. Decrements in body weight bearing performance as a result of increase in BW are a concern for many athletes. However, the current results show that runners or athletes who require running as part of their sport may supplement CR loading without a hindrance in performance because of an increase in BW. Acknowledgements. The authors declare that they have no competing interests. The results of this present study do not constitute endorsement of the product by the authors of the National Strength and Conditioning Association. The authors would like to thank FSI Nutrition Fortress Systems, LLC, for supplying the supplements for this study.